Hello everyone. Today we'll be going over what is the F beta score and when you should use which beta parameter in your binary classification models. We all know about the F1 score, which we usually use whenever we have any kind of imbalance in our data to check for the metric value and accuracy. And as a recap, the F1 score is 2 times precision into recall divided by precision plus recall. Uh, and but there is also another F score which is known as the F beta score. Now, what is the F beta score? The F beta score is the generalization of the F1 score. The F1 score is actually a special case of the F beta score. Now, let's take a recall of how the F score is computed. The F score is a combination of the precision and the recall. What is precision? Precision is how accurate your model is in its predictions. Basically, the true positives divided by the share of true positive plus false positives. And recall is how accurate is your model in predicting the positive class. So that means it is the true positives divided by true positive plus false negatives. You can read all about precision and recall metrics on the internet. If you want, I can make an explainer video going into deeper detail about how they are calculated, but it's pretty basic. But the F beta score is a generalization of the F1 score. The F beta score is calculated by 1 plus beta square into precision plus recall divided by precision. Beta square into precision plus recall. Now, if you break down this formula and say you want to get to F1 score, so F1 score is just F beta is equals to 1 score. So F beta's 1 score is 1 plus 1 whole square into this will be precision into recall divided by 1 square precision plus recall. This just becomes 2 times precision into recall divided by precision plus recall. So F1 score is fine when you want to give equal weight. Remember, this gives equal weight to both the precision score and the recall score. So let's say you're working on a problem where you want to reduce false positives. Let's say you work at a test lab and doing any test for a positive match is very expensive. So ideally, you want to reduce your false positives because you don't want false positives popping up because then you'll have to run a very expensive test to basically make sure that it's not a false positive. So uh, then you don't choose a beta is equals to 1. In case you want to emphasize reduction of false positives for your model, you choose a beta value less than 1. Typically, people choose a beta value of zero point 0.5, which we also call as the F.5 score. Now, how can we prove that reducing beta uh, actually increases the emphasis on false positives? So remember that you want to increase your precision if you want to reduce false positives, right? So let's choose a beta value of very extreme of 0. If you choose beta of 0, the F beta score essentially becomes, so if you see 1 plus 0 square, the precision, okay, sorry, it's precision into recall, sorry. Into recall divided by 0 square into precision to recall. So there's 1 into precision to recall by recall, and this just becomes the precision. So essentially, the lower the beta value, the more emphasis you're putting on the calculation of precision. And with the beta value of 0, the F beta formula just devolves into precision. So the more you focus on precision, the more you focus on reducing false positives. Similarly, if you have a objective where you have to identify, where you have to reduce false negatives, meaning that you have to identify the positive class, then you choose a beta of greater than 1. Let's suppose you work at a cancer screening facility. There, false positives are not that threatening, but a false negative can be threatening to someone's life. So you want to reduce false negatives. So you choose a value of beta greater than 1. Usually, a beta value of 2 is chosen. We also call this the F2 score. Again, to check how much emphasis does a beta greater than 1 gives to the recall, because if you emphasize on recall, you reduce false negatives. Well, let's take another extreme example of beta is equals to infinity. Then this becomes 1 plus infinity square, precision into recall divided by infinity square into precision plus recall. We expand this. This is precision into recall divided by infinity times precision plus recall. Now this entire part will become 0 because I've uh, taking the liberty to make infinity square as infinity because it is another kind of infinity. This will become 0 because anything divided by infinity is 0. And this becomes infinity into precision plus into recall divided by infinity into precision plus recall. So we both sides will divide by infinity, and essentially this becomes 0, and this becomes precision to recall by precision because the recall by infinity is 0, and this becomes precision to recall into precision, and this just becomes recall, right? So the higher and higher the value of beta you choose, the more emphasis you put on recall, and with the maximum value of beta, which can be infinity, that beta formula just devolves into recall. Now, let's take an example to drive home this point that if you vary the value of beta, the metrics do change. So let's import our libraries. I have this dummy example already set up. We uh, calculate the confusion matrix. So the confusion matrix, as you can see, there are 10 true negatives, there are 2 false positives, there are 4 false negatives, and 3 true positives. And then I calculate precision. So the precision is zero point 0.6 and the recall is zero point 0.4. So meaning that f.5 should have a higher value than f2, and f.5 should also have a higher value than f1 because the precision value is higher in this case. Had the recall been higher, it would have been the opposite. So we calculate F1 score, which comes out to be exactly 10 on point 0.5. Now F.5 score will be higher because remember our precision is higher for this example. Similarly, if we calculate F2 score, uh, it should be lower because remember the recall is lower in this scenario. And as you can see, the F2 score is lower in this example, with the F1 score being in the middle, the F.5 being higher, and F2 being 0.45. So in this scenario, in this particular scenario, had you been more focused on the recall or reducing false negatives, you will find a worse metric. If you were more focused on reducing false positives, that is, your focus would be on precision, you would find a higher metric. If you had equal weightage, you would find a metric which is somewhere in the middle of the valley. Hopefully, this clears any doubt you might have about F beta score when to use it, as it is just a generalization of the F1 score. Do follow me at mlexplained.blog. I usually post explainer videos there, and not explainer videos, explorer blogs there, and also do like and subscribe if you like the explanation. Thank you for watching.